So we're going to do absolute values. So in younger years, you would have looked at absolute values, just basic ones. We're going to do them, and we're going to do some graphs today. So if I did the absolute value of -6, absolute values are just the distance away from 0. So absolute value always turns anything into a positive because distances are always positive. So if we have the absolute value of -6, what would your answer be? How far away is -6? 6. If I said, what's the absolute value of 6? What would you tell me? 6. Absolute value is the distance away from 0. It's always positive. So if you take the absolute value of -6, it's 6 away from 0. If you take the absolute value of 6, it's 6 away from 0. If you had 2 minus 3 in the absolute values, you would get the absolute value of -1. What's the answer to that? 1. Okay? So that's your basic absolute values. Now we're going to look at absolute value graphs. So if we look at just the y equals 3x minus 1, let's say. We just look at a linear function. All right. So the very first thing you're going to do is you're going to just graph this line. Now, the important part for absolute values, you guys, because we're going to look at the absolute value of 3x minus 1, and those straight up and down lines, they just mean the absolute value. Okay, so right now we're going to just graph this graph. But the important part for absolute values is to graph whatever the original graph is, but to also know what the x-intercepts are. Okay, so this is just a linear line. So we're going to do our y-intercept, which is -1. And then we're going to use our slope. We rise up 1. We rise before we run. So we're going to go up 3, right 1. If I want to go in the opposite direction, I just go do the exact opposite. So instead of up 3, right 1, I'm going to go down 3, 1, 2, 3, left 1. And they'll put me on the exact same spot. Now what I need in order to do the absolute value of this graph, what I need that's very, very important is I need to get the x-intercepts. And how do I get an x-intercept? I set y equal to 0. What? 1, 2, 3 over 1. 1, 2, 3 over 1. 1, 2, 3. You never go from 0, 0. You go from your y-intercept. Okay, so I need my x-intercept of my original. It's important. So I go 0 equals 3x minus 1. Add my 1 over. And I get 1 equals 3x. Divide by 3. X equals 1/3. And that's important. So I'm going to plot this 1/3 and I'm going to label it. So this is at 1/3 and 0. The x-intercept is important. And now I'm going to draw the graph. Connect those points. And they're not going to work out really well because I drew them kind of crap. But you guys have the graph paper in front of you, so that'll help. Okay? There are like 3 connected together. Okay. So that makes sense how to draw that, right? X-intercept's important. Don't stick it on you, you're just wasting it. All right. So if I ask you then to graph y equals the absolute value of 3x minus 1, when you take the absolute value, what are you doing? Making it all the negatives positive, and all the positives are staying positive, right? So what we're saying is if we take the y of this, we take the y of 3x minus 1 and we take the absolute value of all those y's, we're going to get our new y. So the x values stay the same. You're just going to square root, or not square root, you're going to take the absolute value of the y's, okay, to draw your absolute value. So in order to draw this graph, we draw our original, and we just keep all of our x's the same, and we take the absolute value of our y's. So let's see what happens. So we're keeping this x the same. This point is at -1 and 1, 2, 3, 4. So -1 and -4. And instead of being at -1 and -4, it's actually going to be -1 and... No, we're taking the absolute positive 4. 1, 2, 3, 4. You keep your x and you take the absolute value of your y. So I'm not sure how that's getting 0 or 1, 5, 3, and 2. But the -4 is going to turn to a positive 4. Oh my. Exactly. So then this point is at 0 and -1. So on the original, my point was at -1 and -4. That was on y equals 3x minus 1. On y equals the absolute value of 3x minus 1, it became -1 and 4, because we're taking the absolute value of the y's. Okay? Your next point is at 0 and -1. On the absolute value, it's going to become 0 and +1. You keep your x's, you take the absolute value of your y's. Our x-intercept, which is extremely important to get, was at 1/3 and 0. It's going to now be at 1/3 and 0. It doesn't change. It's invariant. Because if you take the square root of 0, it's just 0. Now, what about my positive points? What's going to happen with all of those? They're going to stay the same. If I take 1 and 2, I keep the x and I take the absolute value of 2. What's the absolute value of 2? 2. It doesn't change. And this one's not going to change. So this is going to be my new, the blue graph is y equals the absolute value of 3x minus 1. Yeah. They're all just 3 up, 1 over, 3 up, 1 over. They just kept going. You do the opposite. So 3 down, 1 left. You go from each point. You don't go from 0, 0. 3 down, 1, 2, 3, 1 left. 3 up, 1, 2, 3, 1 left. 1, 2, 3, 1 left. I did. 1, 2, 3, 1 left. This would be 1, 2, 3, 1 left. It would still get me on here. You start at your y-intercept, which was -1. Yeah, you don't start at 0, 0. So the blue graph, that V graph, is the graph of the absolute value function. Yeah? Makes sense? So in order to draw the graph of an absolute value function, the very first thing you have to do is draw the original. Then you take the original and find the x-intercept. The x-intercept is important because the x-intercept is that turning point. The x-intercepts are what's going to stay the same, right? That because it's at 0, something in 0. When you take the absolute value of 0, it stays 0. So that's your very first positive that's going to be your turning point. The x-intercept is very, very important. So you have to draw the graph and get the x-intercept. Then from there, you can draw the absolute value graph. All right? So let's try another one. So example 2. Y equals -2x plus 2. Draw that. And find the x-intercept. Draw it and the x-intercept. So we go to draw it. We have a y-intercept at +2. So y-intercept at positive 2. Then our slope is down 2, right 1. So we go down 2, right 1. Down 2, right 1. Down 2, right 1. Quiet, please. Down 2, right 1. Up 2, left 1. You just have to do the complete opposite. So instead of down 2, right 1, we'd go up 2, left 1. And to guarantee our x-intercept's right, I'm going to solve it anyways. So to get the x-intercept, I'm going to do y equals 0. I'm going to do 0 equals negative 2x plus 2. Subtract the 2. Divide by negative 2. And x equals 1. So my x-intercept's at 1 and 0, and that's important. You want to guarantee you actually have it. Often you can't, often it won't just put you right to it. You'll have to find it. Like the other one, we had to find a third because it didn't just take us to it. Well, we drew it, but we'd be guessing. Yeah. If there isn't a number, you would always be going 1 right. Yeah. Sometimes I'll give you a whole fraction, like 2/3, and then you'd have to do whatever it is. But if it's just a whole number or an integer, then it's over 1, and then it'll be 1 right. If it's a fraction in as the slope instead, shh. If it's a fraction instead of just a number, so if it was like 2/3, then and it was positive, then you go up to right 3. In this case, it would be always 1 right. Yeah. Yeah. Okay, so we have this. So if we go to draw our absolute value graph, our positives are all going to stay the same. So this one's going to stay here, this one's going to stay here. Positive y's and 0 will stay the same, correct? Because if I take the y's and I take the absolute value of a positive y, it's just going to be what it is. Yes? And all the negative y's, what's going to happen to them? They're going to turn to positive. So if I go to this one, which is at 2 and negative 2, it's now going to be at 2 and 2. And then this one is at 4 and negative 4. It's going to be at 4 and 4. Enough so you can draw a proper graph. So the red represents the y equals absolute value of negative 2x plus 2 graph. We agree? Okay, what if it's not linear? What if it's a quadratic? It's not much different. But you are still going to have to get your x-intercepts. Yep. So what if you have y equals x squared plus 3x plus 2? So you have to draw that one out. So what are we going to need in order to draw this out? We're going to need x-intercepts, and we're going to need the vertex. And instead of using your calculator to find the vertex, I want you to complete the square to get the vertex for practice. So you're going to complete the square to get the vertex, and then you're going to also solve it by putting a 0 in here and getting the x-intercept. Okay? And what's the y-intercept of this equation? 2. So we know the y-intercept right away. And then you're going to do completing the square to get your vertex, and you're going to solve for your x-intercepts. Try that out. This point here is at 3 and 4, because it's at 3 and negative 4. So it should be here. Okay, so to get the x-intercept, you're going to do 0 equals x squared plus 3x plus 2. You're going to factor it. You're going to get x plus 2x plus 1. And so when you solve those out, you get x-intercepts at -2 and -1. Okay, so we're doing the x-intercepts first, and I also told you to do completing the square to get the vertex. I told you to do both. So y equals x squared plus 3x plus blank minus blank plus 2. And then you do 3 divided by 2 squared, which is 9 over 4. So you're going to get y equals x plus 3 over 2 squared minus 9 over 4 plus 2, which is 8 over 4. So y equals x plus 3 over 2 squared minus 1 over 4. So technically, we have our vertex at -1.5 and -0.25. Because we have to draw it, it's better to have it as a decimal. Bless you. So when we go to draw this, we're going to put the vertex at -1.5 and -2.25. So about there. And then -2 and -1. And our y-intercept was at what, did we say? 2, because when it's in this form, our y-intercept is the back number. So that's enough to be able to sketch it. What's another point over here? So you could pick a value, let's say 3, -3. You could plug it in, or you could go to your table of values on your calculator. But we could plug the -3 in. -3 squared is 9, plus 3 times -3, which is -9, plus 2 is 2. So we'd get -3 and 2. Then we have our graph. And that's just the graph of the y equals x squared, right? Now, to get the 2, I literally just plugged -3 into here and found out what my y would be. I picked -3 because I needed a point on this side, plugged -3 into here, and solved for y. It's symmetrical. Yeah. Yeah. Sure, but it would probably be off the graph. Or you could plug into your calculator, look at your table of values, but that's how you do it algebraically. Yeah. All right. So if I want the absolute, yeah. Because how are you going to sketch an accurate graph if you don't know how low it goes or how far it goes over? It's at -1.5 and -0.25. No, I went to -1.5 and -2.25 and drew a dot. It's a coordinate. So just go to -1.5 and -0.25 and draw it. Well, then you're just going to go to where -0.832 is. Draw it. It's a sketch, right? There's no way you can like perfectly tick it to get it to -0.83. Yeah. I just picked an x value on the left, so I picked -3 because it was closest. And then I just plugged it in for the x's. -3 squared plus 3 times -3 plus 2, and got the y value, which was 2. Or you could plug the original equation into your calculator, into your y equals, and get it. Okay, So to get the absolute value of this graph, I now go and keep every positive value and every zero. Because this is going to stay at 0. This, whatever this x is in 0, whatever this x is in 2, whatever this x is in 2, those don't change. Negative 1 and 0, that doesn't change, right? Because if I take the absolute value of their y values, they stay the exact same. Yeah? Then the only point I have is that vertex. It's at negative 1.5 and negative 0.25. It's going to be at negative 1.5 and positive 0.25. So it's going to move here. So your graph is going to do this little curve through it. You're literally just taking the one negative point, guys, and taking the absolute value of it and redrawing it. All of the positive points stay the same. There's one negative point. It's at negative 1.5 and negative 0.25. And you're going to write it as negative 1.5 and positive 0.25. And then you are going to just connect the points. Yep, that's it. No, you literally just draw like this. It's basically being reflected in the x-axis. So because this looks like a curve down here, you guys, enough. Because this looks like a curve down here, you're going to do the exact same curve above the x-axis. It's basically just being reflected in the x-axis. So whatever this looks like down here, it's now going to be up here. You like treat it like it looks like the x-axis is like water when you look into it, or a mirror, right? That's all that's happening. You look at this one up here, it's the same thing. This is your mirror. Here's your reflection. This is down here, but it's being reflected up. That's all that's happening. You're just having a reflection in the x-axis. That's all the absolute value does. Yeah. Negative 3 into the equation, yeah. All right. So y equals 2x squared. No, it's the same, but written totally different. Jeez. Y equals 2x squared minus 3x minus 2. What? There was no. You can. They're your own notes. You can write whatever you want on them. Nope, they're not. All right, so I need you to get the X intercepts and the vertex. And we have the Y already. Do that. So our two X intercepts are at -0.5 and 0 and 2 and 0. Now the vertex is a bit harder to find. Now you could use your calculator like I said, but we're practicing because you have a cumulative after this, which will have this on it. Plus you need to be able to do this after this unit test. Yep. Yep. So we have y equals 2x squared minus 3 over 2x plus blank minus blank minus 2. If you get the blank, you do -3 over 2 divided by 2 squared, which is -3 over 4 squared, which is 9 over 16. Thanks for the reassurance. So y equals 2, x, look one back, minus 3 over 4 squared. Multiply these, you get negative 18 over 16, which is negative 9 over 8. Minus 2, which would be minus 16. Common denominator. Over 8. Yep, we're good. And then minus 25 over 8. Okay, so it's positive 0.75, and what's 25 divided by 8? Negative what? 3.25. Okay, so we have enough information to be able to sketch this. Yes. So we sketch negative a half. Nope, don't know how. Tried for lots of years. And then 0.75 and negative 3.125. And our y-intercept was at, what was it at? Negative 2? So this one stays. This one stays. The arms stay. If we want the arms to be more accurate, we need to get 2 more points, right? Those all stay because if I keep those x values and take the absolute values of their y's, they stay the same because the absolute value of positive y's is the same, correct? So the green part stays the same. Then we take our points that are below and we take the absolute values of them. So this one is at 0 and negative 2. It's now going to be at 0 and positive 2. This is at 0.75 and negative 3.125. But I keep the x and I take the absolute value of the y, and it becomes, if only you could see that, 0.75 and positive 3.12. And then because it's a curve below, it's a curve above, because it's just a reflection, right? It's like it's a mirror image of this, of anything that's below. And the green graph matches the absolute value graph. So it'd be y equals the absolute value of 2x squared minus 3x minus 4. Yes. So whenever we go to graph an absolute value, we graph the original, but we have to make sure that we have the x-intercepts of the original and the vertex if it's quadratic, or at least the x-intercepts if it's linear, right? Why are you giving me that look? Why are you giving that look? What's the matter? I can tell when I can just see she wears her questions on her head. It's -2? Yeah. What? You're going to do some practice questions. Now, one thing I want to state is the two quadratics, the two quadratics that I did so far were both concave up. If it's concave down, you're still going to do the same thing. You're still going to find your x-intercepts, and you're still going to find your vertex. However, your x-intercepts and vertex don't change because the whole thing's above, correct? What would change? This would stay the same. What would change? The two little arms here, right? So this one would get drawn up here. This point, let's pretend this point is here. This point here would get drawn up here, and we'd end up having, yeah, they're just weird shapes. So it would reflect whatever's below up. So it's really a reflection in the x-axis. Yeah, wouldn't change at all. If the whole entire parabola was above the x-axis, it would just be an exact replica. Yeah. All right. Page. We're also going to go over how to draw how to write out the piecewise functions tomorrow, but today we're just going to make you draw them. So page 376, numbers 5 to 8. I should do it like this because I don't want you to do all of them. So 5, all, 6, CEF, 7, and then 8, BDF. Thank you. I feel like I have like there's, what's it called? An echo.